Hi everyone, it's Sorkin. Today we have a problem when we are given a root of a binary tree and we need to find the length of the diameter of the tree. So what's the diameter? Diameter is a length of the longest path between any two nodes in the tree. So for example, in this case, the diameter is either this path 4, 2, 1, 3, right? Or this one 5, 2, 1, 3. In both of these cases, the diameter is equals to 3. We are going to solve this problem using depth first search algorithm. So what's going to be our approach? Let's take a look at the first example. So let's say that we have this tree and the length of the left subtree is equals to in this case 2, right? Because 1, 2. And the length of the right subtree is equals to 1, right? So we are returning, our first rule is that the diameter is equals to left plus right. So 2 plus 1 gives us 3 that we are returning. Let's take another example. For example, in this case, it's not enough just to calculate the length of a right subtree and the length of a left subtree and return the result, because in this case our diameter, our longest path between any two nodes is not passing through our root, so it's passing through 30. So our longest path, in this case our diameter, is this one, which is not passing through our root. So what does that mean? It means that we need to calculate our diameter not just only for our root but for every node. So for each node, we are modifying a bit our rules. So instead of calculating our diameter only for our root, so we are calculating that for each node. So how exactly our algorithm is going to work? So let's put here our diameter here, the value, and initially it's going to be equal to 0. First we are DFS searching and we are updating our value, right? So we are calculating for this node, it's 1 and 1, so it's 2. 2 is more than 0, we are updating that. Now we are going and calculating DFS searching here, right? So DFS searching here, the length here is equals to what? To 1, and here it equals to 2. So now left plus right is equals to what? Is equals to 3. So we are updating that to 3. So now here for this node, right, for 26, again we are calculating the diameter for each node and we are picking the maximum one. So here for the right subtree, the length of it is equals to 1. But how about for the left? For the left, we are picking the one that is the longest, right? So we can add what it means. It means that we can add one more rule. So when we are picking the length, we are picking the one that is left, whatever is the maximum, right? Left or right, and the plus one because of this distance. So in this case, for example, for 26, we are picking either from left or right, so whichever is the maximum. The maximum is in this case 2. 2 plus 1 gives us 3. So we are taking this length of this subtree, left subtree for 26, right? We are taking as 3. So 3 in this case, 2 plus 1, 2 plus also this one of here, right? 2 plus 1 gives us 3. So we have another rule now here. We are picking whatever is the maximum of length left or right plus 1. And again we are updating here our diameter. So in this case 3 plus 1 it's equals to 4. So the same way we are calculating for the 30, and in this case for the 30 it's going to be 8, right? Which is the result that we are returning. First thing that what we do, we are creating a global variable diameter that we are keep updating once we are DFS our binary tree, and we are returning that at the end. For our DFS method, our base case is that if our node is equals to null, which means that we are at the deepest node, so we are backtracking, so we are returning 0 in this case. And for each node, this is our first rule, right? We are calculating our depth of our left subtree and the depth of our right subtree, and we are keep updating our diameter here. And once we are backtracking, so we are taking either left or right subtree, whichever is the longest one, plus 1, that the length of that adding the length of that particular node. And for the time complexity is of n, because we are visiting every node. And regarding to the space complexity is determined by the height of a binary tree, and in the worst case it's gonna be of n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.